A sample of neon gas is observed to effuse through a porous barrier in 3 minutes. Under the same conditions, the same number of moles of an unknown gas requires 5.12 minutes to effuse through the same barrier. The molar mass of the unknown gas is blank grams per mole. Okay, so this is an effusion problem. So we will use Graham's law of effusion. So the formula for Graham's law, when we're talking about time, so that's T1. It just change. So that's T1 over T2 equal to square root of M1 over M2. So T1 stands for the effusion time of your known gas. T2 stands for the effusion time of the unknown gas. M1 stands for the molar mass of your known gas. And M2 stands for the molar mass of the unknown gas. So in our problem, our known gas is neon gas. It's known because it's given in the problem. So all we have to do now is just substitute the numbers. So T1, so the time for the known gas is 3 minutes. So let's put 3.00. So let's just omit the units first. Divided by T2 is the time for the unknown gas, which is 5.12 minutes. And that is equal to the square root, the molar mass of the known gas. So we have neon. So all we have to do is look at the periodic table and look at the molar mass of neon. So that's 20.18 grams per mole. So 20.18 divided by M2, which we do not know because that's what the problem is asking for. Now, we have to solve M2, so let's just use a little bit of algebra. So all you have to do first is to get rid of the square root. So what do you need to do is to square both sides of the equation. So what happens is that the square root will cancel on the right side. So our equation would be, on the right side, we have 20.18 divided by M2. And on the left side, you can actually solve that using your calculator. So 3 divided by 5.12, and the answer to that, you square it. So you will get approximately 0.3433. So that's for the left side. So we will solve for M2. So the next step will be to multiply both sides of the equation by M2. So M2 cancels on the right side. So our equation will now look like M2 times 0.3433 equal to 20.18. So to solve for M2, you just divide both sides of the equation by 0.3433. So that cancels on the left side. So M2 is equal to 20.18 divided by 0.3433, and you will get approximately 58.78. And since this is molar mass, the unit is grams per mole. So G over mole. So the answer to this question is 58.78 grams per mole.